Welcome to the DIY Honda Garage channel. The DTC P2118 refers to a throttle actuator current range performance problem in the Honda Accord models from 2017 to 2023. This issue can potentially affect the vehicle's throttle control system, which is crucial for optimizing engine performance and efficiency. The throttle actuator is responsible for regulating the amount of air entering the engine, thereby influencing its power output and responsiveness. This actuator is typically located near the intake manifold, connected to various sensors and the powertrain control module, PCM. If a performance issue arises, it may trigger the vehicle's onboard diagnostic system to log code P2118, indicating a malfunction, which can be confirmed or pending based on additional diagnostic checks. Understanding this code is the first step in proper troubleshooting and repair. The throttle actuator is an essential component responsible for managing air intake into the engine. It works under the control of the PCM, adjusting the throttle valve position based on the driver's accelerator input and various sensor data. This actuator is usually situated near the intake manifold of the engine, where it can effectively control the amount of air entering. The PCM interprets data from several sensors, including the accelerator pedal position sensor, to optimize engine performance. When DTC P2118 is detected, it indicates that there's an issue in the current range or performance of this throttle actuator. This could result from electrical faults such as shorted or open wires, affecting its ability to operate smoothly. Several potential causes can lead to DTC P2118 being triggered. First, wiring faults such as open circuits or shorted connections are common issues that can disrupt the flow of electrical signals crucial for actuator function. Mechanical failures within the throttle body itself can also be a significant contributor. Components may wear or deteriorate, influencing actuator performance. Additionally, poor connections or loose terminals at the throttle body or PCM can cause intermittent communication failures, leading to performance issues and ultimately triggering the DTC. Regular inspections of these components and their connections can often preemptively catch problems before they escalate into more severe issues. Several symptoms can manifest if DTC P2118 is present in the Honda Accord. One of the most noticeable signs would be an unresponsive accelerator pedal, where pressing down does not yield expected engine response. This could lead to engine stalling or hesitation during acceleration, causing a risky driving situation. Drivers may also notice reduced fuel efficiency as the throttle actuator struggles to manage air intake correctly, leading to incomplete combustion and wasted fuel. Additionally, the vehicle may enter a limp mode, limiting speed and performance to prevent further damage. Being vigilant about these symptoms can lead to timely diagnostics and repairs. The first step in troubleshooting DTC P2118 involves verifying the problem using the Honda Diagnostics System, HDS. Start by turning the vehicle to the on mode, ensuring all systems are active without starting the engine. Clear the DTC using the HDS. This action resets the vehicle's diagnostic trouble codes, allowing a fresh evaluation. Next, slowly press the accelerator pedal all the way down to the floor. This test assesses the throttle actuator's response and checks for any new or pending DTCs that may appear when monitoring live data through the HDS. If DTC P2118 is indicated, you proceed to the next step. If not, you might be facing an intermittent failure, indicating that the system is functioning correctly at this time. For the second step, ensure that the vehicle is turned off and in the lock mode. Utilize the HDS to jump the SCS Smart Control System line, allowing you to monitor diagnostic functions without interference. This jump forces the diagnostic tool to check for system integrity. After waiting for more than a minute, disconnect the required connectors, the PCM connector E80P and the throttle body 6P connector. With those connectors disconnected, you will need to check for continuity between specified test points to ensure that there are no disruptions in the wiring. Test point 1 is the female terminal number 3 at the throttle body 6P connector, while test point 2 is located at PCM connector E number 76. If continuity is present, proceed. If not, repair any identified open in the SG3 wire between the PCM and the throttle body. In step 3, you will be checking for continuity between MTR1 and MTR2 lines to detect any shorted wires. Ensure the vehicle is still powered off and both PCM connector E and throttle body 6P connector are disconnected. Focus on test point 1, located at female terminal number 1 of throttle body 6P connector, and test point 2 at female terminal number 2 of the same connector. Measure continuity between these points. If continuity is detected, it indicates a short in the MTR1 wire to the MTR2 wire that requires repairs. Careful inspection and repairing of any short circuits between these wires are crucial in restoring normal signal processing. If there is no continuity, proceed to the next troubleshooting step. In this fourth troubleshooting step, the objective is to measure continuity between the MTR1 and MTR2 lines again, but in a different configuration. Verify that the vehicle remains off and the relevant connectors are disconnected to ensure accurate measurements. Here, you will be testing continuity between female terminals number 1 and number 2 of the throttle body 6P connector. And the second test point is the body ground. If you find continuity between these points, there is a short in either the MTR1 or MTR2 wire, and you will need to carry out the necessary repairs to ensure correct functionality. By restoring proper connectivity in these wires, you will likely resolve the issue. If no continuity is found, move on to the next step for further investigation. Step 5 focuses on evaluating the throttle body's internal circuit by measuring the resistance across specified test points. With the vehicle still off and the relevant connectors disconnected, make sure to measure resistance between the male terminals number 1 and number 2 at the throttle body 6P connector. Your goal is to check if the resistance falls within the range of approximately 1.2 ohms to 1.0 kiloohms. This range indicates that the internal circuits are functioning correctly. However, should the resistance fall outside this expected range, it suggests an internal failure of the throttle body, warranting its replacement to restore performance. A thorough evaluation at this stage is critical to ensuring ongoing functionality. The final troubleshooting step examines the integrity of the throttle body circuits with respect to ground. Ensure that the vehicle remains in the off mode, with the PCM and throttle body connectors disconnected. For this check, you will again examine the throttle body 6P connector and check for continuity between both male terminals to the body ground. If continuity exists, this indicates a short to ground, and you should replace the throttle body to eliminate this failure source. If there is no continuity, it suggests that the throttle body internal circuit operates correctly, and further investigation might include checking authorized service information or substituting a known good PCM for continued diagnostics. Each step is integral to isolating the root problem affecting the throttle actuator's performance. After completing the necessary repairs for DTC P2118, it's crucial to verify that the problem has been effectively resolved. Start by confirming that the DTC has been cleared from the system using the HDS. Once the code is clear, test the throttle actuator's operation by pressing the accelerator pedal to ensure smooth and responsive power delivery. Finally, conduct a road test to evaluate the overall performance of the vehicle under normal operating conditions. Ensure that both engine performance and throttle response line up with expected standards. Ensuring these steps are carefully followed will help confirm the integrity of any repairs made and guarantee that the issue has been fully resolved. While resolving DTC P2118 is essential, implementing preventive maintenance practices can significantly reduce the likelihood of encountering similar issues in the future. Regular inspection of wiring associated with the throttle actuator is vital. This will help catch any fraying or corroding connections early. Cleaning the throttle body as part of routine maintenance can prevent buildup and mechanical failures from occurring. Lastly, make it a habit to check connections periodically to ensure that terminals are tight, clean, and free of debris. Such measures not only enhance vehicle reliability, but also contribute to overall engine performance and longevity. In conclusion, understanding DTC P2118 and its implications is crucial for maintaining the performance of your Honda Accord. Proper identification and following detailed troubleshooting steps can lead to effective repairs. From ensuring connectivity and wiring to evaluating the throttle body and its circuits, each stage of the diagnostic process plays a vital role in uncovering the root problem. Additionally, taking preventive measures can greatly reduce the chance of future issues, ensuring your vehicle remains reliable and efficient. Ultimately, an informed approach to handling DTC P2118 not only restores functionality, but also contributes to a longer vehicle lifespan. Please like and subscribe to the channel. See you next time.